Morning. Good morning.
Good morning, sir.
So welcome to our class today. Thank you for joining us and starting a new week. Okay. So today, if you join in the classroom, we will be exploring two very important aspects. We are going to talk about different types of data you can deal with as a data scientist or a data analyst. And also, we are going to take one case study on how you can actually get data from a source and then clean it. So we're going to use WHO life expectancy dataset case study. So we're going to go and collect WHO life expectancy dataset from kaggle.com. And then now we see how we can actually clean it by using pandas, NumPy, and today we're also going to use matplotlib so that now we can visualize the data that we are cleaning. So let's start. First thing first, I think it's good for me to go through the description of this program. Maybe if it's your first time. We've been talking about exploratory data analysis, EDA, and we're using Python. So if you're taking this intensive 3 weeks program, it will help you analyze, visualize, and interpret data sets effectively, okay? So you are going to master these Python libraries, NumPy, Pandas, and Matplotlib, and then we are going to use them to manipulate data. You want to uncover some patterns and generate some meaningful insights, okay? So in our first week, because this is our second week, in our first week, we talked about NumPy as a numerical computation library. And then we also did pandas, where specifically we talked about the pandas series and pandas data frame. So in our first week, which was last week, we were able to see how we can load data, how we can clean data, and how we can transform data sets. So for this week, which are week 2 that we are starting today, now we want to apply this knowledge to a real world data sets. That's why we are starting by first. We understand different types of data, and then we take like a WHO life expectancy data set as our case study scenario today, okay? So now tomorrow, that will give us a foundation for now visualizing a clean data set. So I'm hoping that tomorrow we should be starting on data visualization using Matplotlib. Then finally, on the last week, which will be next week, we'll be talking about now projects, capstone projects, where we'll be handling hands-on project by applying the EDA techniques on real-world data. So let's say you can explore the health records dataset and generate some patterns and insight. You can use the same knowledge to retail market. Let's say you can actually analyze data from a supermarket and provide some meaningful insights that the supermarket can use, and so on and so forth. So we said that, hello, can you hear my sound? So we said that, am I audible? Sorry.
Yes.
Perfect. So I think I'm audible. Okay, so yeah, so that we were talking about next week, we'll be using the knowledge that we've been learning from week 1, and now we are in week 2, to a real world data set. Someone can give you data from a school and provide some insights, or a retail store, or a finance data, and so on and so forth. So I can even confidently say that so long as you have some basic knowledge in Python programming, you can now be confidently able to explore, analyze datasets, identify some trends, and then create some very compelling visualization. And this one will be setting a very strong foundation for our later topics on data-driven decision making. So let's proceed with that one. So I want us to go to continue with the program. So you'll be checking your e-learning portal. You'll be uploading some very realistic questions that you'll be doing, so that now you're able to understand all the aspects that we're talking about here. So just want us to go direct. I want us to go direct to the case study that we are doing. So this is one. So I want us to start by exploring different types of data. So let's start from there. So make sure you have Kaggle account. Make sure you've logged into your Kaggle account. Like this is my account. Okay, make sure you've logged into your Kaggle account, because the life expectancy World Health Organization data set, we are going to export it from kaggle.com. So you make sure you have Kaggle, because today I want to show you how you can get data direct from Kaggle and use it in your project, okay? So make sure you have this account logged in. So in the meantime, as you are creating this account, let's talk about some different types of data that you can use in your data cleaning process, okay? So there's something I wanted you to see. Just a minute. Yeah, so here, so in the meantime, you can be creating your account with kaggle.com if you don't have one. If you have one already, make sure that you've logged in to your Kaggle account. So basically today we want to talk about the different types of data you can work with and how you can apply a case study by cleaning data from an industry. So if you go to the curriculum here, this is what I wanted you to see, that I hope you can see it here from the description, is that before cleaning data, very important, it's important to understand the different types of data that we encounter in data sets. That is very important, okay? So you're going to notice that data can be categorized into different types based on its nature and its usage in the analysis. So this is very important aspect before cleaning data. So with that, this one in mind, now let's explore some various types of data that you will be encountering in your data cleaning process. So we are being told that it depends with the nature of the data. The data can be textual, can be numerical, can be date, or the usage. Okay, we'll be talking about discrete data, continuous data, and so on and so forth. So I hope you even have something to note, because this is very important. You can note it somewhere, like in a notebook, so that you would always be keeping in mind about these different types of data that we have. So let's start. So very important is that, number one, a minute. Yes, hello. Sorry for that one. So let's proceed. So let's start by exploring the different types of data that you can handle in your data cleaning process. So the first one, it is good to know that we have a structured data and unstructured data. Okay. So starting with structured data, here, it is actually data that is organized in a predefined format. That is, a structured data is normally organized in rows and columns, okay? You're going to notice that if you want to get structured data, they are mainly found in databases, spreadsheets, or data tables, okay? So a good example of structured data are the Excel files that we deal with, the SQL databases, or the CSV files. So this is the source. So if you have an analysis and you're told that we'll be working with a structured data, then automatically you know that the source of this data could be the spreadsheets, databases, or CSV file. And I can confidently say that structured data are the most popular ones that we have. Most data that most people interact with are actually structured data. So just keep in mind that a structured data has a predefined format. That is, the data is organized in terms of rows and columns. So they are normally called the tabular data. Very important. The most popular one. We're going to use them a lot in our machine learning classes. So on the other hand, now we also have unstructured data, okay? So unstructured data, they do not have any predefined format or organization. So a good example of unstructured data is the text data, the image data, the video data, or the audio files. All these are also data that we have. So where do you get these unstructured data? So you can actually get them from social media posts. I can even say that social media is one of the popular sources of data we have currently because most people are actually active on social media. You can extract data from people's emails. We can extract information from PDF reports or customer reviews. So what you are noticing here is that we do not have predefined format. So now the question could be, how would you work with unstructured data? So this one will give us a topic called natural language processing. So we're going to learn about natural language processing so that now we're able to work with data that do not have any predefined format. It will be a very, very interesting topic to deal with unstructured data, okay? So that is the first one. So please keep in mind we have the structured data and unstructured data. This one, we have the predefined format. Here, we don't have the predefined format, okay? Very important. Number two, as a data scientist and a data analyst, you need quantitative and qualitative data. So starting with quantitative, as even the name can suggest, they are countable. They are countable. So normally we refer to them as the numerical data. So in the data space, numerical data are normally called the quantitative data because they can be used for counting or measurements. So that's why we are calling them quantitative. On the other hand, text data that we deal with are what we call the qualitative data. Okay, so let's understand quantitative data in more details. So one thing is that they are normally used to represent numerical values, and therefore they can be used for mathematical computation and statistical analysis. So in terms of quantitative data, we have actually subdivided them into two types. So we have quantitative data that is discrete, and we also have quantitative data that is continuous. So if we say we have a discrete quantitative data, then it normally consists of whole numbers. That means that they are countable values. So a good example of discrete data, let's say the number of students in a class, the number of hospitals in a city, and so on and so forth. So they are normally consisting of the whole numbers. On the other hand, we also have the continuous quantitative data. That means that can take any value within a given range. So they are normally measurable. So a good example is, yes, life expectancy is measurable. Okay, you can say that, let's say somewhere in India, life expectancy is 72.5 years. Or your height, you can say that your height is 5.8 feet, or the temperature today is 36.5 degrees Celsius. So this means that continuous data, they actually provide data in a given range, and they are normally used for measurements. So one thing to remember about continuous data, which are very popular, is that they are in fraction format. On the other hand, discrete data, they are in their whole numbers. So if you can even remember in Python, we were talking about integers and floats. So we said that integers are the numbers with whole numbers. So here we can refer to integers as discrete, and we can refer to floats as continuous. So I can even say confidently that in our data analysis or data science procedures, we work a lot with continuous data. Okay, very important. So apart from the quantitative data that you said they are numerical, we also have qualitative. So qualitative data are normally referred to as the categorical data. Okay, so these are data that represent categories or labels instead of numerical values. Okay, so you're going to use them in machine learning to do classification, or in clustering to do some groupings. So we have different types of qualitative data. So the first one we have is what we call the nominal. Very important, the nominal data. So a nominal data are any category without any order or ranking. So we just have any category without order or ranking. For example, we can have a nominal data like gender. So we have male and female. So these are nominal. Why? They are nominal because there's no order. We cannot rank male and female. For example, we have the names of the countries like Kenya, Uganda, Tanzania. They are still nominal. We don't rank them. We can even have the eye color. There are those people of brown, blue, green. So these are still nominal data. So something to remember about nominal data is that there is no any order or ranking. Very important. So we are going to use them a lot in our grouping. We'll be talking about grouping. So this will actually be very important to remember about the nominal data. Now from there, we also have the ordinal data. And these are categories with a meaningful order or ranking, but no fixed numerical difference between them. For example, you can actually have an ordinal data to talk about the education level. So you can say that there is an order. Someone can start from primary, follow to secondary, then you go to tertiary. So this is what we call an ordinal data because there is some kind of order. Another good example of an ordinal data is something like customer satisfaction. So a customer can have low, medium, or high. So you can even say that low is the lowest order, high is the highest order. So we have some kind of order, or something like the economic status to those countries with poor, middle class, and wealthy citizens. So we have some orders to check. So just to remind you that if you're working with qualitative data, they are normally called categorical data. And in these two, we have nominal, where we don't have any order or ranking. And now we have ordinal, where we have a meaningful order or ranking, but we don't rank them with some numerical difference. There's no numerical difference in them. So just to remind you is that categorical data normally represents the text data that we have. So we'll be later calling them objects, okay? Now from there, we also have the third type of data, the ones that we call the time series and cross-sectional data, okay? So starting with time series data, we can say that they are data that is collected over time or regular intervals. So we are going to use time series data to analyze trends and patterns. For example, we can have a time series data to represent the annual life expectancy from the year 1990 to the year 2020. So these are time series data because it was collected over a period of time, okay? I can actually have a time series data to check your profits from the month of February to the month of August. So that is a time series data, so long as it's collected over a period of time or at a regular interval. Maybe we can talk about the weekly reports, okay, and so on and so forth. So on the other hand, we also have what we call the cross-sectional data. And we're going to see that cross-sectional data are collected at a single point in time. So we can use them to compare different entities. So for example, life expectancy in multiple countries in the year 2020. So we just have a cross-sectional data to represent data that was collected at a single point in time. So for example, we can check, let's say here in Kenya, we can check the KCSE 2024 results. So these are cross-sectional data because they are results that are only represented at a single point in time. So please notice the difference. Time series data, they are collected over a period of time and they can provide you with some trends. They're going to see that one, or some patterns. So I'm very sure those people are doing Forex trading. You should be very aware about time series data because normally those graphs that we normally see, they normally represent a trend. Let's say a 1 hour trend, 5 minutes trend, or a 24 hours trend. So they are normally referred to as time series data. And then now finally, in the field of different types of data, we also have the primary and the secondary data. So this is something we learned some in our high school, and we saw that a primary data is data that is collected directly from the source for a specific purpose. So if you're dealing with a primary data, then probably you could be collecting this data from surveys. So you go to a field and do a survey. We can generate it from an interview. So you can interview someone like a doctor. Let's say you want to understand causes of diabetes in your machine learning model. So you can invite a specialist, an oncologist, and then you conduct an interview. So that is what we call primary. Or you can even perform direct measurements. So these data are very rich with information, but one thing you're going to notice is that they are very, very expensive to collect, and sometimes they are time consuming, as you're going to see. So most people refer to them as first hand, because if you're actually working with the primary data, then you actually reach with information that you can get, okay? The only disadvantage about primary data is that they are expensive. You need to prepare on how to conduct the surveys. You need to prepare for the interviews and questionnaires. You need to prepare to collect the measurements direct from the source. And this could be also time consuming. So you're going to notice that most data are secondary data in such a way that secondary data is data that has been collected by someone else for a different purpose. Okay, so for example, today we are working with the WHO life expectancy data. So this data is secondary because it was collected by the World Health Organization. Okay. Another good example of a secondary data is you can go to the government and collect the health record. Let's say you want to do health record analysis. So you don't have the primary data, but you are getting the secondary data from the government. Or let's say you want to do some company financial reports. So these reports, you have collected them from the company, so we refer to them as secondary. So you're going to notice that most data that we have are secondary, but if you want to have data that has rich information, you can just go direct to the source, conduct the surveys, perform the interviews, and do the measurements so that you have what we call the first-hand information. This could be time consuming, it could be expensive, but you could get unmeasurable insights from the data. So now coming back to our WHO data set, based on the different types of data we mentioned. So please, I just want to refer to them very fast. So we talked about structured and unstructured data. We've talked about quantitative and qualitative data. We've talked about time series and cross-sectional data. And finally, we've talked about primary and secondary data. Now let's try to compare with our WHO life expectancy dataset. So this data that you're going to use, is that it contains different types of data. That's why we were supposed to learn the different types of data so that we can clearly understand any data set that you have out there in the field. So if you go to the WHO life expectancy data set that you want to download right now, we'll be having some numerical data. So this is what we'll be calling the quantitative data. And in this manner, we have the continuous. So we say the continuous are the ones in a range. So for example, we have countries with GDP per capita, which is continuous, and the population, which is discrete. Yeah, population is discrete. GDP per capita is continuous. Then in the same data set, we are going to meet some categorical data like country names that are nominal, because we've said that a country name, there is no any order or ranking, a region, which is still nominal. But income classification, that is ordinal, because we have high income country, we have middle income countries, and we have low income countries. And we're going to see how income classification affects people's life expectancy. And then finally, we are going to see time series data in such a way that we'll be having data. This data has been collected over a period of time. And we are going to see that this data was actually collected from the year 1990 to the year 2020. So it's actually a time series data. And confidently, I can also say that it is a secondary data because it was collected by WHO. So just to go back here is that anytime you work with a secondary data, the first thing you have to ask yourself about this secondary data is that, is it credible? Okay, is it credible? So you'll have to provide the source, like I've been mentioning that the life expectancy data set that we're using was collected by WHO. So most people can say that it might be credible because WHO, it's actually a worldwide and a recognized organization that we have. So anytime you present a secondary data, someone might ask you about the credibility of the data that you're using, okay? Because you can actually have data that is biased. Some people, maybe we could have data that is biased in terms of race, or it could be data that is biased in terms of the region. So I can even give you a good example. In politics, I think in the year 2022, we were having opinion polls that was being presented by, let's say, like Sinovet. So most people are asking whether is that poll credible? Is it biased to some people? Okay, because it is secondary, it is being presented by a company, so it could ask about the credibility of the data that we are getting. So that is very important. It's always important that if you have a secondary data, you need to verify the source, because the source could be providing wrong information to the audience, okay? So with that one, I want you to open the link here, and now we can start. So if you click on the link I've shared below here, let's click on it. If you click on the link I've shared here, it should be taking us direct to the WHO life expectancy dataset. So if you are not able to access the classroom, I can also share the link to the dataset on the chat. So let me share it on the chat. And now you're welcome, Simon. So I've shared the link. Now today we want to work with this case study, and we want to understand it. So this is just the content of the data set. You can go through it. I don't think we have time to go through it, but it's good you understand it, because in some of the data analysis project, you will be provided with the context of the data, and also you'll be provided with the content of the data. So as a data analyst, you cannot just do any analysis without understanding what you're dealing with, okay? Yeah, so and I think there is kind of a lot to go through, but I think if you have time, you're going to go through it. But it's good for me to go to what was the inspiration for collecting our life expectancy data. I think it was collected for almost all the countries in the world, if I'm not wrong. It was collected from all the countries in the world, 193 countries, and so on and so forth. So this was the inspiration. Number one, World Health Organization wanted to know whether does various predicting factor which has been chosen really affect the life expectancy. So if we have these factors, what are the predicting variables that could actually affect your life expectancy as a human being? Could it be your income? Okay, could it be the region? And so many other factors. So they wanted to know that one, so that because you are going to notice that we have countries with high life expectancy, and we have countries with low life expectancy. So we're going to notice that countries like Japan and Germany have a very high life expectancy. On the other hand, countries like Afghanistan have low life expectancy. So what could be the factor that could determine the life expectancy of a person? Okay. So also WHO was inspired to know whether should a country having a low life expectancy, let's say a country that have a life expectancy that is less than 65 years, increases healthcare expenditure in order to improve its average lifespan. So they wanted to know whether these countries that have low life expectancy, if they can increase the budget on healthcare, would it affect now their life expectancy? Will it be higher? Okay. So they also wanted to know whether how does infant and adult mortality rates affect life expectancy? They wanted to know. They also wanted to know whether, yeah, we'll be talking about correlation here. So we're going to see correlation, and they wanted to know whether we have a positive or a negative correlation with your eating habits. So in such a way that the types of food you eat, does it affect your life expectancy positively or negatively, or your lifestyles, how you live every day? Let's say you work 8 hours a day. There are those countries you work 15 hours a day. There are those countries we work 13 hours a day. Does it affect your life expectancy, or the exercises? Or if you smoke, or if you drink alcohol, how does it really affect your lifespan as a human being? So they also wanted to know whether you are going to see how interesting it is, that what could be the impact of schooling on the lifespan of human beings? Because there's an analysis you're going to do, and you're going to notice that if those countries that have really maintained on schooling, especially the European countries, their lifespan is better than countries that have not invested much on schools, especially countries, most of them here in Africa, and so many other ones. So I would really advise you that if you find time, you can actually go through the context, the content, and the inspirations of the data. So the acknowledgement is that the data was collected from the WHO and the United Nations website with the help of this guy and this guy here. So it looks like the data is credible, so we can clean it and then later use it for our further analysis. So if you are ready there and this is your account, just click on download. Okay, let me try this one. If you don't want to download, let me try this one. I hope it would work. If it doesn't work, we're going to download it direct. I think I would try it out here. Let me just see. Okay, I can press it here. Let me see whether it will give us the path. I hope I have Kaggle Hub. So a minute, I want to try to see whether we will simplify our work, or initially we were supposed to download this data here as a zipped file. Let me just be downloading it in the meantime. So you're supposed to download this data and then upload it in your Google Colab environment. But let's see whether, yeah, so Fred, you're asking, you're hoping whether the life expectancy is the same as the lifespan. Yes, life expectancy is how long do majority, like for example, here in Kenya, let me just see what, but you're going to see that on what is the life expectancy in Kenya. So we're being told that life expectancy in Kenya is around, according to the 2022 data set, it's around 62 years. That means that majority of Kenyans, they reach 62 years, majority. So if you go more than 62 years, then you are like living your bonus here in Kenya, because majority have not passed 62 years. So most people die around this age here in Kenya. So if you die, let's say someone has died at around 40 years, then that means that the guy did not reach where the majority is. So you wanted to know why. If you pass this life expectancy, let's say someone has lived 80 years age. 80 years of 80 years. We want to see why could that be the reason. We have countries like, let me just show you a country like Japan. Let's see, Japan or Germany. So you can see a country like Japan, according to the 2022 source, their life expectancy is 84. So this means that most people live up to 84 years of age. So you want to actually compare what could be those reasons why countries like Kenya, where majority lives up to 62 years of age, and countries like Japan, where most people live up to 84 years of age. What could be the difference? Could it be mortality rates, like infant mortality rates or adult mortality rates, and so on and so forth? So definitely, yes, life expectancy is very similar with the lifespan of a human being for a particular region that is now. I'm not sure about the US. So US, 77. I think Japan is the highest, if I'm not wrong, but we are going to check and see the highest one in our analysis. Let me try Germany. I'm sure Germany is also very high. Yeah, Germany is 80. Yes, I was actually somewhere there. Germany is 80, and so on and so forth. Or how about a country like Afghanistan? Oh, okay, we are still close to Afghanistan. Okay, that could be very interesting. Let's try countries that are Colombia. Like Colombia. 73. So looks like our Kenyan life expectancy is very low. So we want to see what could be the reasons why. I hope I've answered your question. So I was talking about so let me see whether we have the link to our data set. So being told that if you generate the link, let me just try to see whether this will reduce our work. Just a minute. So in the meantime, please be downloading the data. In case this one fails, we have a plan B. So I can now import pandas. I'm sure we did it last week as payday. Then I can now say, okay, let me just import all of them. Then now I can say our data is equal to, using pandas, we are going to read the CSV and then print our data here. So I just wanted to confirm whether if I pass this link, I'm not sure whether it's going to access the data. So let me just confirm. Copy this one, and I can now paste it here. So if it works, then it looks like at least it will save us a lot of time. If it doesn't work, we go. It looks like yes. How about if I try this one here? Try this one. Let me try this one here. I think at some point you are going to learn how to read data direct from the link. But for today, it looks like it's still disappointing us. So we just have to download and read it here. They are still not able, so I think we need some access to do this one. So I just want to remove this one and this one. So we just do it the normal way so that now everyone can understand what we are doing. And now we can start doing our analysis. So I hope you have downloaded the data. Just click on the link here. Just click on the link here. It will give you a zip file. I hope you can see the zip file. Yes, I think Bet you found it. Let's try. That's good. Let me see whether it would work. So according to Bet, looks like, okay, let's try. Let me go to the charts. That could be very, very nice. So let me try this one. Copy that one here. Perfect. That's good. Wow, that's good. Oh, we didn't provide the full access to the data, the link. I think that was the issue. That was the issue. Just confirm with me. So I think that's good from that. That's good. Where you can actually, okay, let me just have the entire link. So according to Bet now, that is very good. You could just, okay, I'll share these codes so that I'll share these codes. You will first need to download it as root according to Bet here. So let me just add a code cell exactly right there. So first you need to download the path. So if you run this piece of code here, it will provide you with the path. And then from the path, you're going to add the name of the file, life expectancy data.csv. So after this one, then you're going to copy this one here. And this will save us a lot of time. I'm very sure. And now you're going to have this one. Okay, you can just have it on a separate code cell like this one. So you first need to run this one so that you get the path. And the path for this one will be actually this one here. Okay. So let me share these two pieces of codes according to Bet, then you can try. In case you get an issue, let me know in the chat. We are really here to assist you. So that is the first link, the first code. Then this is the next one. So that was very, very nice, Bet. That is nice. So copy that one, and then we share it here. Perfect. Good. So you start with the first one, and then you're going to read it here. So this is actually how we are going to read our data. So in case you get a challenge, you're going to let me know, okay? So now that was the first one, and up to now we have our data. So in the next module here, in the next module, so mark this one as complete. We are going to upload a quiz so that we see whether you've understood the different types of data you can work with. I think it looks like I didn't log in. I should sign in. So we're going to see how you're going to work with them. We're going to provide some assessments so that we determine whether you've understood the various types of data later during the day. So you can be checking your portal. We should be uploading the quizzes. So complete that one. Now let's transition to cleaning this data using pandas and NumPy. So let's go through this one very, very fast, and then we write some very interesting codes here. So I want to go through this one very, very fast. So now you have data, you've collected it from the data source, WHO, Kaggle. You've understood the various types of data we have. Now you want to start cleaning it. So before we start cleaning the data, we need to import the relevant Python libraries. This is something we're going to do. These libraries will provide us with very powerful tools for handling and processing data. So these libraries, we are going to use pandas, and we're going to use it specifically for reading, manipulating, and cleaning data. So it will be providing us with functions to handle missing values. We are going to have functions to detect duplicate records. We're going to have function to perform data transformation. We are also going to use NumPy in our numerical computation. Okay, let's say you want to handle a missing value or perform any mathematical computation. We'll be working with NumPy. And then later Matplotlib will be very useful, especially when we want to visualize our data. So for example, outliers, we will be using data visualization to identify missing values, outliers, or any unusual trend within our data. So then after that one, we are going to read our data. Make sure, I think we should be doing this one by one. So let's go ahead. Let's go ahead. This was the data. So I want you to create a new notebook. Just create a new notebook here. Just create a new notebook here. We just do it together as we follow through the notes. So create a new notebook. Generate a new notebook. So please assign it a name. Make sure it has a name. So we are going to call it data processing. Then case study. So this is just a case study I've picked. And then basically we are using WHO life expectancy data set. Okay, so that is what you want to do right here. So the guide notebook that I've used will be this one here. So, and then this will be the notes that we are using. So we're being told that step one in our data cleaning is to import the necessary libraries, okay? So let's start by importing the necessary libraries. So we want to import pandas, numpy, matplotlib, and seaborn. And I'm sure you know why we need all these libraries. So pandas for reading, manipulating, and cleaning, numpy for numerical computation, matplotlib and seaborn for data visualization. So let's go ahead and import them right here. Let's go ahead and import them right here. I think I need a comment to say importing the necessary libraries. So let's go ahead and import. So we can say import pandas as PD. So we are going to call pandas PD. This is the alias name. We are going to call numpy NP. We are going to call matplotlib. We pick the pyplot module as PLT. So in matplotlib, our data visualization library, there is a module called pyplot that will be using it in our Python plotting. And then we can actually assign this name PLT. That is actually the most common name that we normally use to import matplotlib. And then there's also a very nice seaborn library that is, and a very nice Python library for visualization that is called seaborn, that we're going to call it SNS. So make sure you run this one, ensuring that you have all the necessary libraries needed for your data visualization. For your data visualization. So we have imported the necessary library. Make sure you execute it here, and they should work. So that is our step one. So as it's executing, we can now explain why. So that is the reason why here. So if that is the case, then we have done in step one. We have all the necessary libraries that we need. Step two, now we need to read the data. So after importing the libraries, we need to read the data set, and then we can store it into what we call the pandas data frame. So remember we said a data frame is made up of pandas series. So this will allow us to work with the data effectively. And the data set is typically stored in a CSV file and then can be loaded using pandas.csv function. Then from there, we are going to check the head, the info, and even the shape. So let's do the step two here. Let's perform step two. Let's perform step two. So we're being told, now step two, that is when I had highlighted in the chart. So let me first go back here. Add a code cell, reading the WHO life expectancy. Dataset. Let's do that one together. So we were told, according to, I think it was Bet, yes, Bet told us that first thing first, we need to go to the Kaggle hub and then download the latest version of the data from this link here. So I can copy this one here. And paste it here. Then we can even ignore the warning. So import warnings. And then we can ignore the warning. So there are some warnings that we get. I want to ignore them. So I'll share this code. So just run it here. Yeah, so we've downloaded the data and we have the link to the data here. This is the link to our data. So now we can read it here. I want us to read it here. According to Bet, then we actually, I wanted to call it data. So we call it data. Have it here. I wanted to call it data, not PF today. Let's call it data so that now we check. Okay, this one I think you're going to check it later. You can remove it. Just call it data. Just call it data. And then you have it right here. So those are the two very important steps. Let me share this one to give us the link, the data set, sharing it here. And then from there, you need to read the data. Then make sure the variable you're using is data for today. Make sure you're using variable data. So let me also share this one on the chat. So now I can ask anyone with a challenge up to there. Anyone with a challenge up to there, especially on reading the data here. So make sure you're able to read the data here and get a green light, a go ahead that you're good to go. Tick, just need to see the green light and how long it took. So how many, I did ignore this warning, but still, I don't know why. Yeah, but it's still okay. Still no problem. Still, so long as it works, then that's okay. So any challenge up to there? Okay, according to the notes here, this one here, you are being told that after you've read your dataset using the pandas.read CSV function, you can actually display the first rows using the head function so that we understand the structure. Let's do that one. And use this one. Add the code cell here. So the first thing I want to do, display the first rows. So you said we're going to use the head function to understand the structure. So let's do that one together. Let's do that one together. So we just have to take our data and then we display the head. So if you say the head, by default, it will actually give you the first five. I hope you're seeing my notebook. So it will provide you with the first 5 records, where in this structure we are seeing the country, starting with the alphabet. So the first one is Afghanistan, 2015, the year, the status for that country. So we're going to see how many status we have. We have developing, developed countries, the life expectancy. Like for Afghanistan, 2015 was 5. 2014 was 59, and so on and so forth. We also have adult mortality, infant death, alcohol, percentage expenditure. There are some conditions like hepatitis, measles, polio, total expenditure, diphtheria, the prevalence of HIV, the gross domestic product, the population, the thinness of, like, actually this one determines the hunger or malnutrition actually for children between 1 and 19 years. So their thinness, the thinness of children between 5 to 9 years, the income, composition of resources, and the schooling. So this is the data we want to use so that we can do our analysis based on WHO on life expectancy. That's a very nice question from anyone with a challenge. Is there a question? I think I saw a question. With a question that I saw. Okay, so it looks like we're good. In case you get a challenge, please let me know. Please let me know. And I hope you are seeing my screen. I hope you're seeing my screen. So going back to the notes that we did on pandas, let's just keep remind about pandas now. Why do they come to play here? Starting with panda series. So remember we had said that a panda series, it's data that is represented in a single column. A good example here, we can say that the country is a series of countries. Here is another series. Yes, so Fred is saying that the PD is not defined. So probably you have not imported this one. Make sure you run this one first. Make sure you run this one first. Make sure you run this one first so that you define your pandas and then now use it to read your data. I think that could be the challenge you're getting. Make sure you run it and you see a green light here. And then now, because you've defined your pandas, you can now use these pandas to read data sets in your program. I think I could copy that one for you again. So make sure you start with importing the libraries. Importing the libraries. So make sure you run this one first so that you define all these libraries that you want to use. Just like Anita has mentioned, make sure you import all these libraries. You do that one here and you run it here. Make sure you do that one. Then from there, for you to read the data, I'm not sure whether even this one is necessary, but it's good to have it. You can now copy this code on a new code cell. And basically, this code will give us the path to the data set that you want to read from Kaggle Direct. I think that was demonstrated by Bet. So we were getting some challenges, but Bet clarified that indeed, if we're using this kind of code, we can provide the path so that now we're able to read data directly from the internet. So make sure you import the libraries. If you copy this code and run it, you're going to get the path. And then finally, you can now read the data using the path. Actually, we should have, let me first share this one. Actually, we should have even made it easier. Here, we could even say the path, because the path has been stored in a variable. How about if you pass the path here? See what will happen. Because the path was generated in a variable, so if I read the path, or as a string, probably. Let me try something out here. Sorry. But this should work. Not there. I've not added the name of the file. So I think let's just go with the one we had that was provided by Bet. I think that was okay. So just read it direct from here. In such a way that after getting this path, you need to provide the file that you want to read from that path. So now I'm hoping everyone is okay up to there. So you start with importing the libraries, you get the path, and then you read the data from that particular path. So path is like the location of where the data has been hosted on Kaggle Hub. We'll see whether there is a challenge. Oh yes, also you're being told that you can actually add the path. This is also alternative. That's very nice. You can actually concatenate the path with the file name. Yes, you can concatenate the path plus the file name as a string. That should also work. Thank you, Simon. That is good. I can even demonstrate it here. That I think that was nice. To say that I have the path. I have the path. So remember we are talking about concatenations in strings. So I can concatenate it with a string, which is actually the name of the file. So now I don't have, I think it was live space expectancy. Just copy it from the chart. So this is very nice. That's one. Then I can share it here. I can share it here. Yeah, that would work. That is very nice. This should work in such a way that we are combining the path with the file name that you want. That is very nice, Simon. So just use whichever the way you want. It will always work. So that is one way you can do it. Or alternatively, we can also maintain the original version that was shared by Bet here. Perfect. So you can either do it this, provide the entire link, or just have the path plus the file name as we've been demonstrated by Simon. So those are very nice demonstrations. So let's proceed. I'm hoping that now we are good. Let's demonstrate. I'm not sure whether we even are going to cover everything. Perfect. So I'll share that one for you. So I would say that if you call the data.head, it will display for you the first rows. It will display for you the first rows. And this is important for you to understand the structure of your data set. Okay, let's say so for instance, I want to see the first 20 records. Then definitely we are going to see them here. These are the first 20 records. Okay, so it looks like this data was collected from the year 2000 all the way to the year 2015. Okay, from the year 2000 to the year 2015. And then every country, we have the status of the country, we have their life expectancy, and so on and so forth. So I was trying to talk about pandas series, pandas data frame, and NumPy arrays. So we say that if this is a series, every item in a pandas series is indexed here. So we have the indexing in such a way that the first record is at index 0, the next record at index 1, and so on and so forth. Now from there, in each item in the country series, this is what we call a NumPy array. So it's an array of all the items in that series. It's an array. So that's why we want to learn NumPy array. So for example, if you have this array here, so 65.0 life expectancy is at index 0, and this is actually an array all the way to the last one. So this is a NumPy array that have a column. So now if you combine multiple series for the country, for the year, for the status, all the way, now that is when we get the pandas data frame. Yeah, so I think that should be variable name. in such a way that if you have decided to work with data, if your variable name is data here, then you should be saying data, okay? You should be saying data. If your variable name is df, remember, if your variable name is df, if you try to run this one, you're going to get an error because remember your variable name, the problem. Okay, this should be an error. Why is it running? I think it may cache, but if your variable name is df, then you should be saying df here, okay? So please keep in mind about that one. I hope you do not confuse. It's a variable. So a variable is just a symbolic name we use to store data. So if you've decided that the data that I'll get from this link, I will store it in a variable called data. Then now, anytime I want to call this data that I've read, I'll be referring to the name of my variable. I hope now you get it. Katha, I hope you get it such a way that way. Now it should be okay. So please don't confuse yourself. If you say df, then go with df. Data, so that we'll be all the time we'll be calling data dot something in that order. Okay. Okay, now let's proceed. That was data.head. We've seen the structure of the data, and we've actually confirmed that it is made of a pandas data frame. I hope you understand what is a data frame. It is actually when we combine multiple series to form a data frame. Okay, that is important. Number two, we will also to check the info. So let's go very fast. So let's check the data set information. So it's good for us to know the detailed information about this data set that I want to use. And we said in our previous class that we normally work with a function called the info function. So this one will give us, at the end of it all, we're going to get the number of rows, the number of columns, and their data types. Let's do that one here. So we can actually say, let's take my data. So remember, we now call it data. Then you call dot info. If you're using df, then just call it df dot info. So remember, you refer to the variable name that you're using here. So if you check the info, it's giving us detailed information about the data set that we are currently using. Okay. It's giving us the information about the data set that you're currently using in such a way that, let's confirm, we have the country. It is an object. So remember, an object is actually a categorical variable. We have the year, it is an integer. We have the status, it's an object, and so on and so forth. So we have a total of 22 columns. That is the total columns we have. A total of 22 columns. They are here, starting from column at index 0, which is the country, to the column at index 21, which is the schooling. From there, we are being told we have a range, a total of 2,938 records, in such a way that each record has been indexed, starting from the first index, the first record here. This was the first one at record index 0, all the way to the last record at record 2937. Okay. I hope that one makes sense. So that is actually the info. And now we can actually get that we have a total of 16 columns made of floats. So these are the continuous data types. We have a total of 4 columns that are integers. So this is what we had called the discrete. And we have only 2 objects. I think they are here. We have the name of the country. So they are the name, which is actually a nominal. This is a nominal qualitative data, nominal. And let me see another object. And the status. So the status it's an ordinal because it's talking about developed countries. So there is an order where we say that developed countries are higher than developing countries. So that one really makes sense to you. So anytime you want to get dataset information, you definitely have to use the df.info function. Just call your data, and then you run the info function. Then you're going to get the data that you're using, and you're being told that it's actually made of a data frame. It's a data frame because we have combined multiple series so that now we get a data frame. And this is something we did it in details. I hope it makes sense. Moving back to the notes, it's also good to examine the size of the data set by using the shape. Check the number of rows and columns. So let's do that one very fast. So we actually number three, we are checking, before even cleaning, you want to understand our data. So you're checking the size of the data set. So we're going to use shape. Shape, this is an attribute. Shape attribute. And this one will give us the number of rows and columns. So if you're called by data dot shape, so remember it's an attribute, it's not a method. This is an attribute. We are done some OOP, and we are saying that this is a method, info, and this is an attribute shape. So if you run these two, we are actually getting that we have a total of 2938 rows in one dimension and 22 columns in another dimension. So this is actually a 2D data. It's actually that we have the number of rows and we have the number of columns. So it's a 2-dimension data set. I think that is important. Let's now move very fast. Now in the next practice, we want to do what we call sanity check. Sanity check. Yeah, sorry for that one. So I was talking about sanity check, and we're going to see that sanity check ensures that the dataset does not contain any illogical or inconsistent values. So some of the common sanity checks include verifying the number of columns, verifying the column names, ensuring that they are correctly labeled, checking for unexpected values. For example, life expectancy should not be giving us a negative or unreasonably high life expectancy. You cannot say that currently people are living more than 200 years. That should be an reasonably high life expectancy that later we'll be calling them outliers. So we'll be calling them outliers. So outliers are unusual distribution available within our data. So with sanity check, we're going to see data consistency in such a way that each country should have valid entry for different years without duplicate records. And also you can identify incorrect types. So for example, numerical columns should not be stored as text. So this one now should be giving us the basis of our data cleaning. So if you follow through the guide that I had provided earlier, in our step 3, now where we are doing the sanity check, we want to start by number 1, we want to identify the missing values. We want to check outliers. We want to check either we have any garbage or any duplicate record. So let's start here. I think it should be here. So number 1, finding missing values. Finding the missing values. So this is the first one. So sanity checks. So add a new code cell here. So we talk about number 2. And now we are talking about, should be number 3. Should be number 3. Now we are talking about sanity checks, like that one. So the first one we want to start with is A, finding the missing records. So how many records do we have? So to do this one, we'll actually call a function called is null. So remember, null is represented as something that is empty. Okay, so this is a function called is null that you want to use to determine how many records are null. Okay, how many records are null. So then from there, so that now we can calculate the total number of records that are null, we have to do the sum. So you just say is null, and then you do the sum of the total records that we have within our data set. So to demonstrate this one, I'm going to take my data and then call is null function. I want to start with this one. So is null is a condition. It's a condition that will return true and false. So let's see what would happen here. So if you run this code, it will return true, false, true, false. If any record is empty, then it will be noted as true. If a record is not empty, it will be noted as false. Now from there, this is condition. We want to count how many records is returning as true, because we cannot see it through the eye here. We cannot see it here. I don't know whether you can see any record that is empty, but if you want now to calculate the total of any record, all the records that are empty, you just need to call .sum here. So now if you call the aggregate function sum, and then you run it here, we are going to see that these are the total empty records that we have. I hope you can see. So definitely this cleaning, we should be doing them tomorrow because of time. So today we are just going to see the sanity checks, and you're seeing that in terms of countries, we don't have any country that is empty. The year we have 0, status we have 0. For life expectancy, we have 10 records that are empty. Adult mortality, we still have 10. Infant deaths, we have 0. Alcohol, we have 194. Total records that are empty. So moving further, percentage expenditure and so on and so forth. So this is actually the way you can actually perform your sanity check and check the total number of records that are empty. I'm sharing this one with you. It's a very important piece of code that you'll be using all the time in your data cleaning process using Python. So you just say data is null function, then you do the sum. Now from there, there is even another very beautiful function that I want to give you here. So this one gives us the percentage, and we're going to explain how we arrive at that one. So still on empty records, there is a function that we can use to get the percentage of the missing values in such a way that if we have a column that have more than 50% of, let's say we have a column that have 50% of its record empty, then we can actually delete that column because it's having a lot of inconsistencies in such a way that more than 50% of its columns are empty. So to do this one, we have to divide. The formula was we have to divide. We have to divide the total number of empties, with the total records that we have, that are available. So if you run this piece of code here, Then you are being told that life expectancy, we only have a fraction of 0.3% empty. Okay. Alcohol, we have a total of 6.6%, 6.6% empty. Hepatitis, we have a total of 18% being empty. Population, we have a total of 22% being represented as empty. Therefore, it's normally considered that if you have a particular column, let's say this column, and it was actually generating more than 50% of its record as empty, then don't have a choice but to delete it, because now we cannot use its data. It's actually giving us a lot of empty record. Therefore, from here, we can see that there is no any single column that have more than 50% of its record as empty. So therefore, we'll just have to clean them. So I think by tomorrow, we should be doing all this stuff to ensure that all these columns, we don't have any empty records. I think they've already been done here. You can actually go through them and see. So step 4 now, we want to check duplicates. So let's check duplicates. So that was A, B, B, B. We want to check any record that is empty, so B. So we want to checking for empty, not empty, but duplicate, checking for duplicated records. So let's check for duplicated records. So you're still doing your sanity checks. So to do this one, we normally use a function called duplicated. So the function is called duplicated. Okay. So this one will now give us a Boolean, either true or false, whether a record is duplicated or not. Okay. Then after that one, now we call the total sum of the duplicated records in our data frame. So therefore, in this one, we have to say, take your data, call the duplicated function, and this one normally will return for us true, false, as you saw. It should be either true or false. Whether we have any record that is duplicated, record 0 is not duplicated, record 1 is not duplicated, all the way to the last record. If you had a record that was duplicated, then it would have returned true. So in that case, then you'll have to do the sum to get the total number of records that have been duplicated. So if you run this piece of code, I'm sure we did this one in our previous class, and so we have a total of 0 record being duplicated, so that is clean already. Now from there, we can now go to the next one. From there, we can go to the next one. So I want to avoid this garbages, because this is actually where we want to check whether we have any irrelevant, erroneous, or nonsensical in the context of our data set. Okay, I think this one we don't have any. Let's just go now to step 4, and we do our exploratory data analysis. So we go to step 4. So step 4, exploratory data analysis, like that one. Yes. So why do we need to do this one? To go to the notes here, we're being told that EDA will help us to understand the data set before performing any cleaning or processing. So you'll have to do the summary by calling the describe function. We'll have to do the distribution analysis, correlation analysis on identifying inconsistent values using some heat maps and bar charts. So let's do that one here, following the notes that we have here. So we can start by doing a statistical summary. We can start by doing the statistical summary. So A should be A.
Hello,
Yes, hello.
I have a question. Um, for when you're finding the missing values, you find the percentage of the missing values and finding duplicated. Do you remove, if you find there is a duplicated like value, does this
Yes.
command remove the duplicated, or you're just finding?
So for now, that's a very good question. For now, we are just doing the checks to find them. So we've not removed them yet. We are finding them first to identify whether their duplicates are there or not. Then after that one, if you check on the notebook I'm using here, after doing all the checks, now we start by handling them. I think they're somewhere here. I'll show you somewhere. There's somewhere whereby now we'll be handling them, which we actually are going to do them tomorrow. Okay, now you see, we want to see how to treat this missing value in our step 5. We want to remove the missing values. Then we also going to remove the outliers. If we saw we had some outliers, we're going to remove them, and so on and so forth. So right now, we are only trying to identify whether they are present so that now we can remove them later. That is what we are calling the sanity check. I hope I've answered.
Yes, thank you.
Okay, so that's good. I think I didn't check the question. So Kim, you're asking? Okay, I think Kim, you're asking about that very nice question. I think to answer you here, you're trying to understand this one. You're trying to see, for this one to happen, you have to get the total empties. You divide by the total records that we have, so the total records that we have. Then everything we multiply by 100%. So this one will give us the percentage of the empty records that we have. Now, how do you get the total empties? How do you get the total empties? So total, just to explain how this code will actually arrive at it. So the total empties you're getting is by actually taking your data, then you call is null, then dot sum. So this is the first one, the first one. That's the total empty records. Now, how do you get the total number of records? Okay, so let me show you something here. Let's go back here. If you take data.shape, it will give us a tuple. I hope you can see. Data.shape should give us a tuple. So in the first index, it's the number of records. In the next index is the number. It's the number of columns. Okay. So if I say at index 0, I should get the total number of records, which is 2938. Okay. At index 1, I should get the total number of columns, which are 22. So therefore, because I wanted the total number of columns, I should actually take at index 0. I'll show you that one here. Now this is actually representing the total number of columns. So let me just copy this one. Yes, so this one. So these are the total columns. Total records present, not columns, but records present. We need to get them by that function. Then we multiply by 100. And that's why we did df.isNull.sum. We've divided by df.shape at index 0, which is actually the number of records. Then I've multiplied by 100. That's why I was getting the percentage empty records. I hope I've answered you now, Kim. I hope it now makes sense that you divide the total empties with the total records times 100%. Then from there, now you can actually get the aggregate of all the total empties that we have. Okay. So I hope that one's okay now. Then from there, we were actually doing the sanity check. And then tomorrow we are now going to transition to how do you now handle, let's say, for example, how do you handle the missing values? How do you handle the outliers? How do you remove inconsistencies and so on and so forth? Okay, how do you do what is called label encoding? So, so right now we're actually doing EDA, so that now we understand our data set before actually doing the cleaning. And we are starting with the descriptive statistical analysis. So you want to do statistic and check for numerical columns. So this one we had said is df dot, I think it should be data, not df. It should be data. It should be data. Let's just work with data. It will be data here. So we have to say data dot describe. And what you're going to notice is that as on the y-axis, we are getting the statistics, and then on the x-axis, we are getting the number of columns. So remember, we talked about transposing. So if you do a transpose, if you say dot transpose, now the arrangement will be reverted in such a way that on the y-axis, on the x-axis, we get the summary, statistical summary, and then on the y-axis, we get the total number of records here. And what you're noticing is that we've only picked numerical records only. We've only included numerical records, so we can actually say that, for example, the mean, I think there is a function I'll be sharing tomorrow so that we can actually convert these values. So we're getting this, the total summary here for each column that we have here. So this is the first one we can do. Then from there, we can also have B. We can also have B. If you want to include for categorical columns, just like I had mentioned here, this is actually only for numerical columns. If you want to get for categorical columns, that I think we call them objects, we'd have to say data we describe, and then we only include columns that are objects. So the objects are the textual columns, the categorical columns. Then we do a transpose. So if you run this one, then we're getting that we have only two records that are objects. We have the country and we have the status. The total count is 2938. We have a total of 193 unique values. So this means that we have a total of 193 countries that we are actually analyzing. And in terms of status, we only have two. So we have developing and developed countries. So the first item in the object is Afghanistan. We have a total of 16 in terms of the frequency. And status, we have a total of 24, 26, which are developing records that we have in our objects data type. I want to share this too with you. So this is a summary for numerical columns. This is a summary for numerical columns. And then this is the summary for categorical columns. So we'll have to include the objects like that one. Now from there, we can also talk about distribution. So let's check distribution. So distribution, we are able to identify outliers within, not outliers, but how the data has been distributed within our data. Okay. Distribution. So let's have our data distribution. So this one we normally work with a histogram. We normally using a histogram. So in SNS, we normally call it an hist plot. So with an hist plot, we can actually get the distribution of values within our columns. So in this manner, here, so for example, here, we just to show you how to do it this one, let's say I have a column like life expectancy. How has life expectancy been distributed in my column? So to do this one, I can just say using SNS dot histplot. I call the histplot. So histplot is actually located on SNS function. Here, I'll pass my data as data. So my variable for my data is called data here. So the data I'm using is what is called data. And then the column that I want to see the distribution, X, is the life expectancy column, that one. So if I run this piece of code, then it's actually going to give me the distribution. I hope you can see here. So this is actually distribution for a single column. For a single column. This is actually a distribution for a single column. So how to draw a distribution, we normally work with SNS, Seaborn library, and then we call the histplot. And then inside the histplot, we pass the data that we're using, and we pass the column that we're interested to check the distribution here. And then now to actually draw the line, we can actually say that we can also add another argument here. We say kernel density estimation, we give it as true. That is what we call the kernel density estimation. So if you run this one, then it's actually going to draw for us the distribution. So you can actually see that we have the left skewness here. And most of the life expectancy is distributed from the age of 40 all the way to the age of 90. And the highest life expectancy most people have is between the age of 70 and 80. This is where we have the highest, especially around 74. This is actually how we can actually read the distribution. We can also pick another column like, let's try adult mortality. So you can, if you want to take for adult mortality, you just need to pass it here. Just need to pass it right here. Just need to pass it like that one. Then if you run this one, you get the distribution for adult mortality. Okay, so we get distribution for adult mortality. So it's actually on the right skewness here with our density estimation showing that it's on the right skew. So now from there, this is something we're going to clarify tomorrow as we proceed with these visualizations. Using the SNS library, we definitely draw the graph. And then using the PLT, using the PLT, we can get something like the X label, and then X label is what we actually have on the X-axis here. So we can actually say life expectancy in years. So let's say you want to rename, by default, it will just give you the column name, but you want to rename this value. This is what we call the X label. So if you run it here, you should be having life expectancy in years. So the total number. So you can actually say that the other one is called the Y label. So PLT dot Y label. We're going to learn more about these ones tomorrow in our visualization classes. We are now talking about the total count. So if you run it, we are going to see that this label that you provide on the Y-axis is what we are providing here. Alternatively, you can even give the title. So you can even say PLT dot title. And then the title is actually the title for this visual that we provide here. So then now we have the title as the distribution of life expectancy. So this is something you're going to learn more about tomorrow in our data visualization classes. Now the problem is, let me share this one with you so that you can try them out. Now the problem is we wanted to do a distribution for all the total columns we have. So this was only for a single column. It's very easy to do that one for a single column. But now if you were to do distribution for all the other columns, let me just share this one here. So now we're trying to do distribution for all the numeric columns. So therefore, in this manner, we need a for loop. Therefore, and actually say therefore, we need a for loop. We need a for loop to run through or to iterate. Let me just use the right word. We had learned about looping. So we said loopings are used for iteration. So we need a for loop that will iterate through the list. Iterate through the lists of numeric columns. That's why we need a for loop. And that's if you check on the notes that I have here, we've actually included a for loop. So for all the indexes, so if I run, let me start with this one here. Just show you this one here. I just want you to understand this piece of code here. So if you run this one here, it will give us the list of all the numerical columns. So we only include columns that are numeric. Select data types, we only include the numbers, and then we get the columns. Okay. So then we can say, and I hope you can see it's a list. It's a list. It is a list. It is a list. So there, because it's a list, we can actually say that for all the index, so for I, in these columns, I hope you can see these columns that we've demonstrated here, we go through all of them here, and then we generate the his plot in such a way that data will be data, this should be data, and then the x-axis will actually be I. So I, the first index is the year, the next index is the life expectancy, the third index is the adult mortality, and so on and so forth. So therefore, if you run this piece of code, we are actually drawing all the hist plot for the numerical columns that we have. I want you to demonstrate that one. And that's why we were learning about loops. We were doing the loops. Yes, I think they are not drawing. Let me see the reason why. Okay, then from there, let me see. Yes, we need to say the plt.show because we have several graphs to draw. We need to have plt.show for now. See what would happen before I share. Yes, now because we have actually drawing several graphs, we need to have the plt.show, something we are going to clarify in our next lesson tomorrow. So I'm sharing that one with you so that you can try them out. Try them out. So now we are seeing the distributions for all the numerical columns. Okay. So all the numerical columns. So we're starting with the year, go to the life expectancy, we go to the adult mortality, we go to the infant deaths, where we're actually seeing that it's actually less than 250. We go to the alcohol, it's high between 0. Most people don't take it, and few people take alcohol content that is more than 15.0. Percentage expenditure, quantities is very high for people more than 80, and so on and so forth. So this is actually the distribution for all the columns. And then if that is the case, we can actually provide the X label, the Y label. Let me just use these ones here. Not this one. Yes, this one here. So we can actually provide the X label, the Y label. We just show you something here very interesting. Copy this one. Then we can paste them here. So whereby we are providing the X label, make sure they are inside the indentation. I want to ensure they are inside the indentation. That one. And this one. That one. So we have the I think this one we don't need to have them. It's only the title that I wanted. And then now you're going to notice that we need to go, so we need to have a formatted loop here, formatted string, and then we pass the name of the column as index. So here we just pass I, that one. So I refers to the name of the column. So the first one, I will be this one, and so on and so forth. So if you run this one, I think it now will be giving us all the title. I hope you can see distribution of year, distribution of life expectancy, distribution of adult mortality, and so on and so forth. And I hope you're actually appreciating that using loops, we are able to actually do repetitive tasks within a very short period of time. And that one there. Yeah, so that maybe you can try this one, Fred. You can try this one here. So basically, that is how you're going to see the distribution of these several columns that we have here within our data set. So now from there, tomorrow, because now I can see it's already 11, and we were supposed to cover all this notebook, we would start from, tomorrow we are going to start from, let me just say, tomorrow we are going to start from, let me just confirm. Detection using box plots. Then from there, we will taking outliers. We will proceed with getting the relationship. So we're going to talk about correlation analysis tomorrow. Very important topics. So tomorrow we are going to also talk about what we mean by correlation analysis. And then this one will be using heat maps. We're going to see what is correlation and how do you visualize correlation within your graph. And then finally from there, we will be using, we'll now be handling all the other aspects, starting from how do you handle missing values, how do you handle outliers, and so on and so forth. So I think I have a challenge from a friend. You're asking, the name is not defined. Probably, let me just say. Why is it not defined? Yes, this should be data. Sorry, this should be data, not df. I don't know why it's working, but just call it data. Data. Similarly, here it should be data. Data like that one. This should be working. So let me share this one with you. I think it should work now. So if you see df is not defined, looks like you're working with df instead of data. So now try this one. Try out this one here. Charts. I'm sharing this one now. So try out this one here. I think this one should work now. That one. So if you have df is not defined, then probably you're working with df instead of data. So make sure this is data, this is data. You remove any aspect to do with df. So any other question up to there tomorrow? So today?
Excuse me, sir.
Yes.
Can you please remind me in the code the last code you've sent, plt.title, what does f do in that bracket?
Okay. Good question. That's a good one. So that's a good question. Here, there was a point we were talking about strings. There was a point we were talking about. Let's say I have a variable like, let me say, I have a variable like name is equals to Eric, okay? Name is equals to Eric. And I want to print this variable inside this string. So remember we talked about the string formatting. So in the string formatting option, what you have to do, you just have to provide the F. Now that the one you've asked, you need to provide F. And then you now actually place the variable name here. Just say now Eric. So if you run this one, you're going to see that it will actually be saying distribution of Eric. Let me just show you that one. Can you see? All the other aspect is showing distribution of Eric. So the idea was we were trying to print a variable inside this print statement. That is the first scenario. Now the question is, instead of me printing Eric all the time, I want to be printing the name of that column. If this is the year, I should be saying the distribution of year or distribution of life expectancy, distribution of adult mortality. So the same way I've printed my name, I can go ahead and print I. And remember, I represents the name of each column that you have selected here. I. So I represent for I in all the names of the columns we have. So if I were to print all the columns in this graph, I hope it's making sense, I should just place here I. If I put here I, then it should be now be saying distribution of, let me just show you now, let's run it again. So I hope you can see in the first scenario, it has printed the distribution of the first column, which is here. Maybe to make sense, I think I should print this one.
Excuse me, sir, can you please share your screen?
I'm not sharing my screen. Oh, sorry. What happened? Sorry for that one. Yes, I was talking about, I hope you can see my screen now.
Yes.
Perfect. So maybe I would have to repeat, but just a minute. Just one of them said something. Let say something here. Perfect. So this F talks about string formattings that we did on string. We said if this is a string, so long as we have it inside the quotation mark, this is a string, and I want to print a variable. So I'll have to put the F here so that I'm able to format this string with a variable. So for example, if I have a variable like name is Eric, I can actually provide the name of the variable here. And I hope you can now relate that. If I run this one, all the graphs that we are drawing will be actually saying distribution of the variable name Eric. I hope you can see that one. Distribution of the variable name Eric, which does not make sense. Distribution of Eric. So this one clearly is trying to show us that with F, we are able to print a variable inside the string. Now from there, that's why I printed this variable. I printed this here. I printed this one for you here. I hope you can see it here now. So this one picks all the columns that are numerical. So now if I say for I in this variable that I've printed here, so the first occasion, I will be the year. The next occasion, I will be the life expectancy, and so on and so forth. Therefore, I'll just have to print I'll just have to print I here. I just want to print I in such a way that in the first occasion, I will be the year. In the next occasion, I will be the life expectancy, and so on and so forth. That's why if you run this piece of code, you are seeing that the first one, distribution of year. So this year that you're printing here is when this I was the first index 0. The next one, distribution of life expectancy. This one means that we are printing when I is at index 1, and so on and so forth. That's the reason why we have the F here to do the formatting strings. I hope it makes sense now.
Yes, it does. Thank you.
Okay. So any other question so far up to there? Any other question? Yes, I even Kim had explained that one for you. It's to call the information in variable. Yeah, that is the case here. That is true. So this I, we are calling the information for I here using the formatting strings. So we are now able to print I here. So this was very important, but it looks like we've not been able to complete all the aspects here. So we'll just be proceeding with this notebook tomorrow, where we'll be starting with how do you detect outliers using box plots. We're going to see what are outliers and why do we need to remove them before analysis. And then from there, we're also going to talk about what is correlation analysis. So we're going to talk about positive correlation, negative correlation, and how you can visualize correlation using the heat maps. These are what we call the heat maps. So we're going to use them to visualize correlation. Then also we can work with scatter plots. I think we also have some scatter plots. So using these scatter plots, we're also going to see correlation analysis tomorrow. So with that one, I want to stop there for today. Please check your portal. Should be adding some exercises that you can try so as to understand what we've learned today. So any questions so far up to there? Any other question? Perfect. So I will be sharing this notebook in the portal so that now we can be using it now starting tomorrow. So have a good day. Let's meet tomorrow. Bye-bye.
Thank you.
Bye-bye.